Welcome back. This second video is going to continue our discussion about arithmetic sequences, and we're going to do some applied problems here just to make sure you got the concept. Okay, again, big idea in mathematics definitely is, and to recap what we looked at already, we said arithmetic sequences are when sequences that have a common difference. They are always linear when graphed. Therefore, if this is a linear rule for these points here, it is also a rule for the arithmetic sequence. We also said that linear rules are not the only way to look at arithmetic sequences. We derived a general rule for arithmetic sequences going through a certain process, and we got this rule. So that doesn't look quite like the last rule, but make sure you know this rule and not just think of it in the linear fashion, because this rule is the one that's in our formula booklet and the one we will often use in the work we do for this topic. So again, write down this rule and let's use it now. So here's the first problem. We have this arithmetic sequence, and let's see if we can determine the general rule using the linear method. So yeah, I just said let's focus on the new rule, but to start this question, we're going to start with the linear rule. So the method, remember, you look for the slope, how much is it going up by, and then go back to the zero term to get the y-intercept. Okay, so if you look at that as term 1, term 2, term 3, and so on, then you go back to term 0 and you get this value. And that allows you to create the linear rule very quickly. Again, the rising value, the common difference of 3, is our slope, and our y-intercept here is the value you get when you drop back to the y-intercept, -1. Great, that's easy. Let's see if we can make the general rule using the formula we were just given. So again, that's this formula. So write this formula, plugging in the values you know, and see what formula you get. Okay, so there's our general rule for arithmetic sequences. We can write u sub n equals 2, which is the u1 value, plus n minus 1 times the d value of 3. So this looks a little different than that. But then we have step C here. Simplify this rule to see if it becomes this one basically. So multiply through combine terms, see if you can turn this into this. Okay, begin with that. Multiply this part by 3, so 3n minus 3 when you multiply this through. Combine the 2 and the -3 to get -1. Hey, and voila, there we have it. That rule looks just like this one. So this arithmetic rule, they should be the same, right? They're giving a rule for the same sequence. Two different forms. Make sure you're familiar with both linear and this one. And now use the rule that we've created. You can use this one or this one to find the 10th term in this sequence. Okay, so there's our rule. We're looking for u sub 10, put 10 in here. It will allow us to find that the 10th term is 29. We can confirm that by going from the 6th term to the 10th term, term by term here, adding 3, adding 3, adding 3. We'll notice we'll get to 29 as well. Okay, here's your next problem. Try A in this one. Find u12 and begin with this formula always. Okay, here's the answers for A and B. You can see all the steps here, or I hope it was pretty easy to come up with that. So u sub 12, u sub 9 for this one. Now try C. Okay, in C again we have our D value, and then we can use the general rule to find the 21st term. So this is pretty basic stuff. Hope it's going okay so far. Let's try this one. You have an arithmetic sequence in which u1 is this, D value is this. Find the value of n such that u sub n is 2. So some term in this sequence is 2, and you have to find out which term it is. When you're looking for the n value, it's saying which term, because n represents which position or term of the sequence we're talking about. This one would be pretty easy to begin at 14, u1, and then go down 3, down 3, down 3, and you can get to 2 pretty quickly. But let's do the algebraic approach. So start with the rule and plug in what you do know. Okay, here's the process for this one. We're going to begin with the general rule. We're going to plug in the un. We're looking for some future term that has a value of 2, so we put that in here. u1 is 14, d value is -3. Solve this algebraically by multiplying through, calculating, solve for n, 5. And that should be easy to see again if you just count down by 3, down 3, down 3. You'll notice that by the 5th term you get to this. But start practicing this way for sure. Don't just logic your way to the answer. Always on exams in particular, they're looking for a trail of your work and proper use of formulas and so on. Okay, next one. Let's look at this one. We need the number of terms in the following finite arithmetic sequence. Notice it says finite because we see dot 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 here, which typically implies that it's going to be infinite. However, then it does give an ending value. So basically it's saying here's the first three terms, there's some more terms in between, and there's the last term, and we don't know which one it is. So when it says number of terms, we have to figure out basically 36 here is term number what in this sequence. So again, begin with the formula. It can always begin there, and then plug in everything you know, and usually you'll see that there's one more variable to solve, and then go from there. Okay, so here's the general rule. We're going to put in what we know. We know the term, the mystery term in the future we're looking for, u sub n, is 36. We don't know the n value. We don't know what term number that is. We do know u1 is -8. We do know the d value is 4. Again, solve, solve, solve for n, and you get this. So what that tells us is this is the 12th term. Okay, great work so far. Let's look at this one. We have two terms in an arithmetic sequence, this one and this one. All right, there's two approaches to this, and anyway, let's see if you can figure it out first. Okay, one way to look at this is this. This method is a pretty good one. Most students like this method. Basically, we know u11. But if you remember, when we go from one term to another, we add d values, right? So to get to term number 11 from term number 6, which we know there will be 5 jumps, because it takes 5 jumps to get from term 6 to term 11. Each jump is our d value, right? So that's what we write in this equation here. To get to the 11th term, we start with the 6th term, and we add 5 jumps of the d value, so 5 differences. So I hope that makes sense logically to you. So that's a rule we can start with there. And then you plug in what you know. So you know u sub 6 is 4, you know u sub 11 is 34, and then you say 5 jumps of the d value, and we're going to figure out what that d value is in a minute. So here we have an equation with only one unknown. We solve for d, we get 6. And the question is saying, what's u15? Well, then we can say u15 is u11 plus 4 jumps of d, right? To get from 11 to 15, we're going to go 1, 2, 3, 4 jumps, so 4 jumps of the d value. And then that takes us to, let's see, we're solving it. Yeah, u11 is 34. We know the d value is 6 because we just solved it, and we get 58. So this is a really nice approach to that. The other way to do that one is to basically set up using this general rule. You would write that general rule twice, once for this and a second time for this. I would strongly suggest you try that method right now also, just to get some practice. But basically you'll write the big rule for that, big rule for that. Then you'll have two equations, each one with n and d as the unknowns. And then you use some method, whatever method you prefer, of solving a system of equations. So you can use elimination or substitution, and then you solve, and you should get to the same answer. I'd really suggest you try that method now. Okay, so here's the next problem. We have this sequence. Again, we see first 3 terms, then we don't know how many terms pass, and we get to this term. We don't know what term that is. So this one is going to have a similar approach to the last one. Find the common difference, and then find the number of terms. In other words, find out 50 is term number what in this sequence. Okay, the common difference is 4. We can see that clearly here. It's going up by 4. Then we use our big rule here, put in what we know. 50 equals 6 to this one's much easier than the last problem. Okay, solve that, and you get an n value of 12. That means there's 12 terms in this sequence. Next one, try this. It says the second term in a sequence is 1, and the 7th term is 26. Okay, so in this case, I will try it in that longer method that I was talking about, because this is very similar to that one a couple questions ago. Let's remind you this one here, where you know one term, you know another term, and they're separated by some number of terms. That's exactly what we have in this problem, because you know second term and 7th term, right? So again, we know the second term, so I'm going to write this equation. There's our general rule, u2, u1, and then we put that 2 in because n is 2. There's that rule. Okay, and we know u2 is 1, so I'm going to write that out. So like I told you, remember, you have an equation with 2 unknowns, so that's not solvable. So let's write another rule for the other thing it tells us, which is the 7th term. The 7th term, So u7 equals u1 plus 7 minus 1 times d, because the n value is 7. So there we have another rule. Simplify that a little bit, I get this. So now I have two equations, this one and this one. It's a system of equations because they have the same two unknown variables. I'm going to solve this one here for u1 by moving the d over, and now I'm going to take this and substitute it here for u1. So in this equation, I put that 1 minus d right in here for u1, and then you can solve this. Now it has only one variable, d here, so combine those, solve for d is 5. So this is the slightly longer approach, but it's good, I'd say, in this point in the course to practice a little bit of solving systems of equations. It becomes a skill that's essential as we proceed through the course. So this is good practice. Maybe you'd also, to go back, reverse on this one, try the other approach, the one we used previously in the other problem. So you can keep trying both approaches when you come across a problem like this, just to get practiced in both ways. So now we have our d value, find the 100th term. So we're going to find the u1 value first of all. So you can take this d value and you can plug it in either here or here in either equation to get the u sub 1 value, the first term. And now you can use the general rule to find the 100th term. And it is 491. All right, almost there. Let's look at this one here. Wow, same one. I'm just going to keep throwing these same kinds of problems at you. So this is the same kind of problem where you're given one term, another term. Again, try both methods. There's no loss in mastering both at this point, so try both. Okay, let's check our work. Let's see which method did they use here. They used the one where we have u12 and then u9 plus 3 jumps makes u12. So they did that. Check your work, and we have our answers here. All right, great job. You can do it. You are now a master of arithmetic sequences, I hope. There's 3 more key formulas to come in this unit. Good start, and be ready in the lesson next time to work through some practice problems. Great job.